Hello. Today we're starting the third concept from, if you remember last week, I showed you some of the difficult concepts we'll be adding on to the net present value calculation. I spoke about inflation, remember? I spoke about working capital. I spoke about relevant cost, the relevant cash flows. We've dealt with all of this and we've solved questions on them. Yeah, likewise taxation. We've dealt with this as well, which is good. In the previous video, if you missed it, please go back and watch those videos, because today we're going to start asset replacement. We are still on net present value. Yeah, now I want to look at asset replacement concept. Yeah, what are we talking about when we're talking of asset replacement? We're saying you have an old asset and you're asking yourself, you need to change it. Should you change it with asset A or asset B? That is the question. What will you consider to decide whether you are buying A or B? Or should you even be changing the old asset? Yeah, and that is why you're going to be using concept of net present value to answer those questions. Because the answer is, which asset will give you the highest net present value? Is it the old asset? Is it A? Is it B? But before we go into that, let me break it down a bit so that it's very intuitive to you and you can easily relate. If I ask you, what will you consider before you can decide whether you are buying asset A or B? There are a few things that will come to your mind. I'm sure the first thing will be, I'll go for the cheaper asset. So if you look at cost, you will ask yourself, which one is cheaper? So you go for cheaper. What if they are the same cost? Which means, take for instance, they are $5. I'm sure you'll now also be thinking of, okay, what about the output? If asset A can give me higher output, I'll go for asset A. So you're looking for higher output. But what if they give the same cost and the same output? So 5 per year. This one also give 5 per year. And I'm sure you now remember, there's another factor that I need to consider. Then I will consider the lifespan of the asset. So whichever asset has a longer lifespan will be my choice, because if I can get 5 per year for 10 years, I would rather go for asset A that will give me 5 per year for 10 years, unlike asset B that will only give me 5 for 7 years. So you can see there's a lot of moving variables, because the reality is that it will not be this straightforward. It's possible to have cost is different, output is different, and lifespan is different. So you cannot just decide whether you want to do asset A or B on the face of it. And that is why the concept of net present value is very important, and that is what you have to use. Because on the plain view of this data, when you have different variables moving around, cost is different, output is different, lifespan is different, it is not just very straightforward to decide on what asset you're going to use. Yeah, so, and that is why net present value is your choice. However, there's also a bit of twist to the net present value, because now let's look at asset A and B again. And let's assume that asset A gives net present value of 40 and asset B gives a net present value of 35. So this is straightforward, because if NPV is 40 for A, we'll say A is a better asset and B will drop. So we'll replace with asset A. However, most times A and B will have different lifespan. So take for instance, A might have 3 years lifespan and B might have 4 years lifespan. So the question is, what asset are you going to be using? What asset are you going to be using? because this is over 3 years and this is over 4 years. Then you'll be wondering, okay, which one will I use? That is why you cannot just use net present value as it is. And that is why I'm now going to introduce to you the concept of equivalent annual cost or equivalent annual benefit. It's the same thing. The only difference is that if your net present value is minus, which means it gives you a cost, net cost, then that is EAC. Yeah, that is called EAC. And if your net present value gives you positive, then which means is return, then that is EAB. But it's the same concept, because the question is, how do you calculate this? What we are saying is that your NPV over 3 years is 40. Your NPV over 4 years is 35. This is over the whole life of the asset. This NPV over the life of the asset. But what this concept is saying is that you need to annualize that NPV. You need to annualize it. And how do you annualize it? If you remember, if you want to analyze a figure, it means that you want to know, for instance, for this A, you want to know what will be the constant cash flow every year for 3 years. And what is that called? If you remember in the last video, that is called annuity. I told you annuity is the constant. When you have one same cash flow every year for more than 1 year is annuity. So, which means normally your NPV is equals to annuity factor multiplied by the constant cash flow. That is how you could have gotten this. So this constant cash flows that we are talking about here is your equivalent annual cost. And that is why the equivalent annual cost or annual benefit formula is equals to the NPV of the machine divided by the annuity factor. Because sometimes I don't want you to always cram the formula. You need to understand how the formula is being derived, so that even when you are applying it, it's very easy for you. Because I could have just given you this formula for asset replacement, but I had to give you that introduction. Excuse me. So that you can relate with it. So this is in net present value, which is like the present value of all the constant cash flows that you have annualized. And this is the single cash flow that happens every year. If you multiply this by the annuity factor, it gives you the PV. And that is why the PV you are looking for is this. And when you divide by annuity factor as well, it gives you the annualized cash flow. If you remember, if I show you annuity table quickly, look at this annuity table. This is annuity table. Over 2 years, we have factor of 1.97 here for 1%. Yeah. So which means annuity of, if you have 10,000, let me split the screen so you can get it. Yeah. So take for instance, if you have $10 per year, and over 2 years at, let's use 10%. Remember, the PV of this cash flow is equals to the $10 you get every year multiplied by annuity factor over 2 years at 10%. And annuity factor at 10% over 2 years is 1.736. So which equals to 17.36. So in our EAC calculation, what we are saying is that this 17.36 is like the PV, or what we call NPV of the asset. Yeah? And the $10 that we are talking about in this question is our annualized cash flow. So this annualized cash flow, which can now be an annualized cost or annualized benefit, depending on the outcome you get, right? So this is annualized cash flow, and 1.736, which is the factor we used, was the annuity factor. So you can see what we've done here, yeah, is what this formula is talking about. But in this formula, yeah, what we are trying to calculate is this part, which is we're trying to get the annualized figure. And that is why that is your EAC formula. And I'm going to try and solve a question on EAC so that drives it even home better for you, right? Let's look at a question here. Let me try and form a question to make life easier for you, and you tell me how you feel about it. In the comment section, you can ask me questions like you've always been doing. Yeah, you know how to reach out to me. You have my contact, my email is there. Yeah, so always feel free. So take, for instance, if you have NPV again of an asset, let's say is $81.11, and you have cost of capital of 10%. Let's say over 3 years. This is asset A, right? And let's say you have asset B. NPV is 60.57. Cost of capital 10%. However, this asset lifespan is just 2 years. If I ask you, which asset should the company invest in? Remember, because we're looking at asset replacement. So our objective, the way we take a decision, let me make this NPV negative so that so NPV is negative, so it shows that it's a cost. I'll make it so it's a cost. So the objective, or the way you take decision, is that you select assets with cheaper equivalent annual cost, or assets. So cheaper means lower, lower figure, or assets with higher equivalent annual benefit, because obviously you want higher benefit and you have lower cost. So that's how you take decision. So to decide whether we do asset A or asset B, if the NPV of the asset is giving us negative, as we've seen it, we know that those are cost, and which means that we should be going for asset that has the cheaper equivalent annual cost. Now for asset A, what is equivalent annual cost? Equivalent annual cost for asset A is equals to 81, which is the net present value of the asset, divided by 3 years. So then 3 years is 2.487. 2.487, and that gives us a calculator. 81.11 divided by 2.4, that's 32. So that's negative 32.61. So that is the equivalent annual cost of asset A. Now let's do for asset B, because it's also negative, so it also has equivalent annual cost of negative 60.57 divided by, well, this is over 2 years at 10%, 1.736, and that will give us 60.57 divided by 1.736, and that gives 34.9. Negative. So now we have EAC for both assets. A is negative 32.61, B is negative 34.9. And they ask you which asset will you choose. Definitely, because they are both cost, you go for the cheaper equivalent annual cost, and A has a cheaper cost. And that means you will replace your asset with asset A. So that's the choice of asset to choose. Let's do another question, which is an exam question. Ridag plans to replace an existing machine and must choose between two machines. Machine 1 has an initial cost of 200,000 and will have a scrap value of 25,000 after 4 years. So you see that's telling us that the initial cost has been given for machine 1, and likewise we have the scrap value of 25,000 after the 4 years. But we have another option, which is machine 2. Machine 2 has cost of 225,000, right? And will have a scrap value of $50,000 after 3 years. So it also has scrap value after 3 years. Now, annual maintenance cost for the two machines are as follows. So both machine 1 and machine 2 have annual finance and maintenance cost. And what does that mean? It means that every year we're still going to incur this cost on those assets. The only difference is that for machine 1, we're going to incur that cost for 4 years. However, for machine 2, we're going to incur that maintenance cost, 15,000 for year 1, another 20,000 for year 2, another 25,000 for year 3, and after year 3, we are perfect. There are no more costs to incur. Now the question is, with this information that we have, are we able to decide which of the machine? Because now, let's continue reading. Where relevant, all information relating to project 2 has already been adjusted to include expected future inflation, right? So, which means this is the project 2 we're looking at, the Ridag project, right? So, inflation has already been adjusted for. Taxation and capital allowance must be ignored in relation to machine 1 and machine 2, so which even makes it very straightforward, right? So if we already have all of that being accounted for and we've been asked to ignore taxes, so we just need to focus strictly on net present value of machine 1 and machine 2, taking into consideration all of this cost information that we have. So let's work it one after the other. Let's get the net present value for machine 1. Yeah, for machine 1, we know that the lifespan is 4 years. Yeah, unlike machine 2 that has just 3 years lifespan. Yeah, because they've stated it carefully. Now, to calculate NPV, our approach has always been to use our format. Here we have cash flow, we have discount factor, and we have the present value. So we'll start from year 0 as we always do. Right, so year 0, we're going to buy this asset for 200. So I'll work in, let's work in thousand. So year 0 cash flow is minus 200. And we know that year 1, year 2, 3, and 4, we're going to incur maintenance cost. Minus 25 in year 1, minus 29, because they are costs, so they are negative cash outflow. Minus 32 and minus 35. However, in that same year 4, we're going to have another cash flow, which is the residual value of 25,000, but that is rather an inflow, so that will be plus 25. So we're going to make plus 25 in year 4 as well. So let's get our discount factor at cost of capital of what is the cost of capital? Okay, so it's omitted here, because it's probably in the part A and B of the question, right? So I will give you a cost of capital to use at 12%. So we'll use 12% as our cost of capital for this question. 12%. Yeah. So we use 12%. So at year 0, 12%, wherever the percentage, remember year 0 always have discount factor of 1 because the cash flow is happening now, so there's nothing to discount. So we're not discounting it. We'll take the 100% of the cash flow. And that is why the discount factor remains 1 for year 0. For year 1, if you go to your present value table, you have, let me quickly go there and show you. 12%, this is 12%. Year 1 is 0.893. You can see it. 0.893. Year 2 is 0.797. Just under it, and keep going down like that. 0.712, 0.636, and still same year 4, so 0.636. Don't make mistake and assume this is year 5. It's still year 4 cash flow. And if we multiply the cash flow by the discount factor, this remains minus 200. This becomes 22.3. This becomes 23.1, 22.8, and 22.6, all negative, and this is positive 15.9. So what is our NPV? So we add all of that together, 200 plus 22.3 plus 23.1 plus 22.8 plus 22.6 minus 15.9. So that's negative 274.9. So that is NPV, which is negative because it's cost. Yeah. So now we need to get the EAC of machine 1, which is equivalent annual cost. Remember, this is overall NPV. Now we need to analyze this. This is over 4 years. Now to analyze it, which means to make it, what will be the annual cash flow? Our formula is this, which is the NPV of the asset divided by the annuity. So what is the annuity at 12% for 4 years? So 12% is 12% at 4 years is 3.037. So 3.037. So if I divide all of that, I have equivalent annual cost of 90.4. So that's for machine 1. Now let's check machine 2 so that we know which one is cheaper. The same format, year, cash flow, discount factor, and the PV. So we'll start from year 0, year 1, year 2, and year 3. Right? Then we have our cash flow, we have the discount factor, and we have the PV. Year 0, how much is the asset? They've told us, the question says the asset is going to cost 225. So negative 225. And we're going to spend this money on maintenance. Minus 15, minus 20, and minus 25. However, there's a residual value also after the year 3, which is 50,000. So make money of 50. Are we not lucky to have such huge residual value after 3 years of usage? Discount factor remains 1 here, still at 12%. The same discount factor we used up there is what we're still using, 0.893, because it's the same percentage cost of capital. So 797, 0.712, and 0.712 as well, because it's the same 3 years that this is happening. If you multiply all of that cash flow by the discount factor, we have 13.4 negative 15.9, and negative 17.8 here, and here we have positive 35.6. And if we had all of that together, we have 35.6 minus 17.8 minus 15.9 minus 13.4 minus 225. We have negative 236. So NPV equals to negative 236.5. Now we need to analyze it by calculating EAC, and that makes it minus 236.5 divided by the annuity factor. Please don't make a mistake of dividing by number of years. This is NPV calculation. You cannot just simply divide by number of years and say you have analyzed it. You must use annuity factor because it's a present value you are working with. So if you check the annuity table, you have a factor of 2.402. And that gives EAC of 2.402. Then EAC is 98.46. So give negative 98.46. So if you have machine 2 with EAC of 98.46 and machine 1 has 90.4, the question is, which machine are you going for? So it's no brainer. We have said our decision is that the cheaper cost is the asset we're going for. Yeah, and the asset that gives us the cheaper cost is machine 1 with equivalent annual cost of 90.4. And that is it for asset replacement. It's as simple as that. Remember, if this NPV has been positive, then we'll be going for the higher figure, because is that we'll go for something that remove the lowest amount from our cash flow, or we'll go for something that had the highest amount to our cash flow. So please don't get confused. Most times you always have negative NPV because it's about buying an asset and it's about cost and cost and cost. The only benefit you get is scrap value, which most time will never be more than the cost of the asset and all the expenses you have to incur to maintain the asset. But please, if you have any confusion, reach out. But this is where we'll stop on equivalent annual cost. In the next video, I'll be looking at capital rationing concept, and I will solve a question on it as well. Until then, please continue to like the video. That's the only way you can encourage me to keep making these videos, and continue to share with your friends as well and colleagues. All the best. Bye.